Welcome to Brain Vision.
So, with this is question number 23.6. We are given that we have to find out the electric potential energy of the adenine thymine bond. So, and this have two molecules here, so OHN and NHN. And these bonds have this kind of the bonds, so O minus and H plus, or just say that these have four pairs, so O minus H plus, O minus N minus H plus, and N minus N minus. So electric force acts between these pairs, and we have potential energy. So we can find out the potential energy using this formula. So we have given here, and the total potential energy is the sum of the all potential energy between all those pairs. So that will give the actual electric potential energy of the adenine thymine. So we have O minus, which has negatively electronic charge because this is minus here, and this is H plus, so that means that this has plus electronic charge. This N minus has N minus E charge, and again the other one, this other one has minus E charge. We have Q1 and Q2, which is this values, and we know the value of the R. Sorry, there is a mistake here, so it should be just R here, single R. There is no R square here. So coming back to this again, so we have distance between O minus and H plus equals to 0.17 nanometer. You can find this values on exercise number 21.21. So the values are given here. So O minus between and N minus have 0.28 nanometer, and distance between N minus and H plus is 0.19 nanometer, and distance between N minus and the other one, the N minus, is zero point 0.3 nanometer. 1 nanometer equals to 10 raised to minus 9 meter. So we have 1 nanometer equals to 10 raised to power minus 9 meter. So we have to convert this into SI units. So this is SI units. So let me write the formula again, not to confuse it. 1 by 4 pi epsilon naught Q1 Q2 over R. So that's the potential energy between any two pairs having Q1 Q2 charge, and distance is between them is R. So let's calculate part A first. So we have potential energy between O minus H plus, which is equals to, let's say we have U1, this one equals to 1 by 4 pi epsilon naught, has value 9 10 to 1 9. So Q1 is over this charge, which is negatively charged, so we put negative here, and both have same electronic charge, so we have 10 to minus 19, so we put the square here. And distance we already know, which is 0.17 nanometer, and so we have minus 9 meter. So using calculator we have find out the value, which is equals to 1.35 into 10 to the power minus 18 joule. Now U between O minus and N minus, so we have U2. So both are negatively charged, so negative negative multiply, if we multiply negative negative, so this gives the positive value. So we have n 9 to 10 to the power 9 into 1.6 into 10 to the power minus 19 square, and the distance is 0.28 nanometer, so we have 0.28 into 10 to the power minus, sorry, 0.9. So let me write it again, so not to confuse it. 10 to the power 9 into 1.6 into 10 to the power minus 19 square over 0.28 into 10 to the power minus 9. So this gives us value 8.22 into 10 to the power minus 19 joule. So we have these two value now. So now finding out the u between n minus and h plus, or n minus bond h plus. We say it u3. So one is negatively charged, one is positively charged. So we must have minus here. So this becomes 10 to the power 9 into 1.6 into 10 to the power minus 19 square over the distance is 0.19 nanometer. So this becomes 10 to the power minus 9. This gives us value minus 1.21 into 10 to the power minus 18 joule. So record this value. We will use these values. So we have another one, u between n minus and the other one n minus. So we have u4 equals to 9 to 10 to the power minus, so n to the power 9 into 1.6 into 10 to the power minus 19 whole square over distance is zero point 0.3 into 10 to the power minus 9 meter. This is 0, so don't confuse it. So we have plus 7.67 into 10 to the power minus 19 joule. Now total potential energy. So we have total U equals to U1 plus U2 plus U3 plus U4, and put in the values, you will find out that this is equals to minus 9.71 into 10 to the power minus 19 joule. Minus is simply saying that the system is bounded. So this is A part. So that we have this A part answer. That's your answer for A part. Now the part B says that compare this value with the hydrogen electron atom. So we have hydrogen atom which has one electron and one proton. That means the charge are minus E and plus E. So we have U equals to 9 10 to the power 9 into 1.6 into 10 to the power minus 19. Since one is negative and one is positive, so we put negative here over R. You can find out the value of the R between hydrogen and electron using Google or maybe within this book. And the R between hydrogen, or to say the proton and electron, is equals to 0.0529 nanometer. So we have all these values. So we put this value 0.0529 into 10 to the power minus 9. So this gives us value minus 4.35 into 10 to the power minus 18 joule. So this is very small, so smaller. So and this is large number or big number than this one. So that's your answer for part B, and that's it. Thank you.